I'm going to show you guys something here really quick. As you can see here, I've got voltage on the cell, 130 volts. That should be more than ample to create sufficient amount of hydrogen. You can see our waveforms are in phase, however. We have in phase waveforms. And as you can clearly see, in phase waveforms do not produce like out of phase waveforms. These, although we do have potential difference and a fairly high potential difference, we don't have, and I do love the amperage here though, but we just don't have the waveform we need to create the hydrogen like we normally do. Here again, I'm going to pause this. I've got 120 volts across the cell, which should be giving a substantial gas output, and it is not. And here I want to give you a reasoning for this. Since we have in-phase waveforms here in this case, we have 0 volts. Then we have increasing voltage, back to 0 volts. Here we have negative voltage, coming back to 0 volts, and then positive, and then back to negative. We have this wave shift, or whatever you want to call it. Regardless, we do not have positive potential in the cell at all times, and we do not have negative potential in the cell at all times. This might as well just be microwaving the food at that point, because you're just oscillating the water. So if you don't have equal opposite polarity pulsing through that cell, you're not going to get the maximum production that you should. Wow, that's one cell at 36 volts. I got me here a ppm meter so we can test our water. I also happen to get my hands on this nice water purifier system, and we're going to put some water into our cells, some purified water. Here we have some just general tap water from my city water here, and we can see that we're at 603 parts per million, and you know, that's not really great at all. So we're going to fill it up some water here. We're going to test it, and unfortunately this system produces just a trickle of water. Got a little bit of this water poured out here, and we are seeing 24 parts per million here. So that's a drastic decrease from the tap water that we have here. Let's fill up some of our cells here. It's going to take maybe all day, and we're going to see what happens. Just for reference, in this specific configuration I will be testing here, which is all inductors on that secondary inductor B. 6 amps, 6.3 amps, 31 to 32 volts, about an amp at the cell, about 135 volts at the cell. This is our output presently with pre-contaminated water here, 4 cells. All right, take this in here, just like that. Actually filling up pretty quick there, not so bad. All right, that water is down to 16 parts per million now, so we're somewhere between 25 and 16 parts per million in our cells. All right, here we go. Test with purified water at approximately 20 parts per million. Let's start the clock. Not quite any production. It's about 12 kilohertz right now.
My ears. Wow, am I glad that's over.
There's 200 volts with some production. Only 250 milliamps at the cell. Pretty equal opposite polarity pulses. Barely any gas production. I'm guessing because of the reduced particulates, there's increased resistance in the water, driving our amperage at the cell down, which leads me to believe that amperage is in fact doing work in the cells in addition to the voltage in the cells doing the work as well. Certainly not in the gas production anywhere near what we were. Different operational mode, grant system 195 volts at the cell, 250 milliamps, nice EOP, pretty much on the money. we are not getting production as we did. So perhaps this apparatus works best with contaminated water, which may fit its function as a water purifier greater than a energy generation device. Here in a different config, I've got 187 volts at the cell, 238 milliamps EOP, and just barely any production. Not impressing.
This is Stan's Revenge.